Hi guys, these are our notes for Unit 4B.1.1, Modeling with Math. We're going to be doing this one right here, linear word problems, on slides 6 through 8. So start us off, we need a piece of paper. Go ahead and put your title, Notes 4B.1.1, linear word problems. Start off with general form of a linear equation. So we're just going to be looking at the same one we looked at yesterday. We're going to be looking at y equals mx plus b, but today we're going to have word problems. It's not going to say, here's the slope, here's the y-intercept. It's going to give you a real world scenario, and you have to come up with your equation. So for m, okay, yesterday we talked about m as slope. We want to think about m as like our rate of change. So when we're reading our word problems, we want to look for things like per person, per hour, per mile, whatever it might be. It's something that happens over and over. The y-intercept that we're going to be looking at today is basically going to be like our starting point. It's some sort of fixed amount. It only happens once. So those are kind of some things that we're going to be looking for to decide which part of our problem is our slope, which part is our y-intercept. So here's our first example. We're going to have 3 examples total. You can write this one down. It says Lynn is tracking the progress of her plant's growth. Today the plant is 5 centimeters high, and the plant grows at 1.15 centimeters a day. A, write a linear equation to model the height of the plant after D days, and B, how tall will the plant be after 20 days. So one thing we need to keep in mind too when we're doing our problems is that a lot of times we don't use X and Y when we're doing our like word problems. So this problem is talking about a plant's height, how tall the plant is. So we want to use H for our height. And then down here it told us that it grows at 1.5 centimeters a day. So we want to use D for our day. So we don't always use X and Y. So part A starts, write a linear equation to model the height of the plant after D days. So instead of y equals mx plus b, we're going to use H equals md plus b, I guess. So what we want to do is we want to decide our slope. Okay, so remember this one is your rate of change. It's per person, per hour, per whatever. So if you notice that it says the plant grows 1.5 centimeters a day, so 1.5 centimeters per day. That means that our m is that 1.5. So H equals 1.5 D plus B is our like fixed amount, our starting point. It only happens once. So basically that's going to be the plant's starting height today. So that's going to be that 5 centimeters. So our equation is just H equals 1.5 D plus 5. Then the next question, part B, says how tall will the plant be after 20 days? So how tall will the plant be? So we're going to plug in 20 for D because it says 20 days. So we'll plug it in. And then we simplify. H equals 1.5 times 20. Well, when you multiply something by 10, you move the decimal over once, so it'd be 15, and then double that, so it's 30. 30 plus 5. And then we're going to go ahead and add them together. So we get the height is equal to 35 centimeters. Okay, so that's it. So today on your homework, you're going to have a bunch of writing them, and then you'll have just a few of solving them. All right, let's go ahead and get our Unit 4B workbook. This is Unit 4B, and we're going to be on page 9. Unit 4B, we're starting off on page 9. So example 1 says, Aaron wants to have his company's logo printed on tablet computer cases so that he can give away the cases as part of a marketing campaign. A specialty printing company will charge Aaron a $750 fee to design and print the personalized cases, plus the cost of the actual cases. The price of each case is $3. How many personalized cases can Aaron purchase if his budget is $1,200? So part 1, I don't expect you guys to always do this, but you can think about it in your head. At least it says write an equation in words for determining the total cost to produce the personalized cases. So in order to get the cases, you can't just buy the cases. You have to pay a design fee plus the cost per case. So our problem says write an equation for the cost of n cases. So it says they will charge Aaron a $750 fee. That's a flat fee. That's your y-intercept. So 750 does not get attached to your x. And in this case, we're not even using x. It says n cases. So we want to put the per case, it's per cases, the slope part, the rate of change, that's the part that gets attached to the end. So plus the cost per case, that's going to be $3, right? $3. So it'd be 3n. And then we want, our total budget is $1,200. So we're going to set it equal to $1,200. And then it says part 3, determine how much money Aaron will have left to spend after paying the fee. So basically, we want to know how much it's going to be if you had the $1,200 minus the $750 fee. So we get 3n is equal to, I think it's 450. Right, 7 minus 1.5. Okay. Then number 4 says determine the number of cases Aaron can buy. So the last thing we have to do is just divide both sides by 3. Now we get n equals 150. So last thing, number 5, just says use the equation to check the result. So if you had a $750 fee plus $3 for 150 cases, we want to see what that's equal to. So we get 750 plus 450. Does that equal 1,200? Check. So our answer is 150 cases. Well, what was the question? Yeah, how many personalized cases can he purchase? He can purchase 150 of these little cases for his marketing campaign. So again, you don't always have to do this part, but it helps you. This is your design fee, that's your flat fee, and then the cost per case, that's like your slope. All right, number 2, we're not going to do number 3, we're going to do number 2. It says Chloe's driving back from college for summer vacation. She fuels up her gas tank and then drives for a certain amount of time before passing a roadside attraction. She drives on without stopping, and 3 hours after leaving her college, she's driven 120 miles past the attraction. 7 hours after leaving her college, she has driven 400 miles past the attraction. Write a linear equation in one variable for the distance Chloe covers in t hours, and describe the domain of the linear equation. Assuming that Chloe travels at a constant speed without stopping, use the equation to determine her speed. Then determine how far she traveled before she passed the roadside transaction. So it asks us for a lot of things. Write a linear equation, describe the domain, determine her speed, and then how far she traveled before she passed the transaction. So asks us a lot of questions. All right, so what we're looking at time. Time is usually your independent variable, that's your x. Then we have, and our time we have is in hours. I'm just going to put hours. And then we have her miles that she's driven. So I'm going to create 2 points. I'm going to use how many hours she's gone and how many miles she's traveled. So this statement right here says 3 hours after leaving her college, she's driven 120 miles past this attraction. So I'm going to write my point as 3, 120, 3 hours, 120 miles. And then I have another one that says 7 hours after leaving her college, she's driven 400 miles past. So then my second point would be 7 hours later, she's driven 400 miles past. Well, I can use 2 points to create a linear equation. We did that yesterday. So if you recall, the way yesterday that we would write our equation is we would first have to find our slope. So we find our slope using y2 minus y1 over x2 minus x1. So I'm going to label my points. I have an x and a y X and a Y, and this is 0.1, so I'm going to put 1s, this is 0.2, so I'm going to put little 2's. So when I plug them in, I get 400 minus 120 over 7 minus 3. So 400 minus 120, no, I'm not using my calculator, but it's 280. 280 divided by 4, well, 28 divided by 4 is 7, so it would be 70. So that is your slope part of our equation, right? But we're not using like y equals mx plus b. We're using its time and her miles. So it's distance for miles, and then her time is in hours plus b, like that. All right, so we know m, so I can plug in 70 for m, and then if I want to find b, I got to plug in one of my 2 points. So it doesn't matter which one, I'm just going to plug in this first point, but this is what we did in our homework last night. So 120 equals 70 times 3 plus b. 70 times 3 is 210, so I'm going to subtract 210 on both sides. I get negative 90 equals b. So now that I know m and b, I can plug them in. We're not using y equals mx plus b though. We're using distance is equal to 70t minus 90. So how other questions I asked, and the last two determine her speed and how far she traveled. This would then be her speed, would be 70 miles per hour. And then this would be her, it says determine how far she traveled before the roadside attraction. So this is miles before the attraction, whatever it was. Maybe she was driving by the world's tallest thermometer in Baker, California. Who knows? Is it Baker, Nevada? I don't know. On the way to Vegas. The last thing we haven't done yet is describing the domain. So your domain is your like your stipulation, kind of like on your x's. So to determine it, we need to know that our distance that we're traveling has to be a positive number. So what we're going to do is we're just going to set our distance equal to 0 and then just solve real quick. So I'm going to add 90 to both sides. I don't have a whole lot of room, so I get 90. I wrote equals to, but technically it has to be greater than or equal to 0 because it can't be less than 0. It doesn't have to be exactly equal to 0. Your distance just has to be greater than 0. Equals 70t. Divide both sides by 70. And I get that t has to be greater than or equal to, because I wrote it the wrong way, I apologize. It would be this direction. Has to be greater than or equal to 0. Your t has to be greater than or equal to 0, and that'd be 9 over 7. So your time has to be 9 over 7 in order to get a positive distance. So basically that's how far I guess she was traveling before she hit the roadside attraction. 97 hours, 90 miles. And that's it. Okay, so we're going to put these notes into our new digital notebook. So we have slide 6, slide 7, and slide 8. And then your homework tonight is 8 quizzes.